called the Launchpad 430 that costs €4.30 or $4.30, sorry, where they didn't do documentation for this board. They said, hey guys, we put the board here, we make it very cheap, and you document it. It didn't really work that well. Because they were not us, sorry. So then we also work very much in bringing fun aspects of applied science. By concentrating, we frame the knowledge. It's like, we know if you work at a high school, as a teacher, you have 45 minutes to bring the students from this to this. And by the way they go home, you want them to go home feeling that they learned something. So you need to provide them with that path. It's almost like you teach somebody how to play theater. You teach them how to become Macbeth and talk to the thing here. Just this thing is an Arduino board. Hello, Arduino board. Can you show me the way to physics? And then it shows you acceleration, for example. Then a very important concept for us is peer-to-peer education. Is mouth-to-mouth dissemination. It's like we use the hacker method, mostly because we are hackers, all of us. So I teach Tim, since you came, I have to use you, I'm sorry. And Tim will teach his dad. I know this is how it works in this case. So, and then he will teach somebody else. But at every iteration, since I will not stop by teaching Tim, I will start teaching Jon, then we will go at the power of 2, adding more and more people to the equation, and it will be growing and growing. Then this is a very important aspect. We don't own the platform. We let people own. We let people own the platform. By making it the way we make it, we let you take ownership of it, own parts of it, document your part, take your share, and share with others. We also changed the way a laboratory looks like. I worked at those laboratories where you go with the white pajamas, where you have to get into this air pressure environment so that the dust comes down and it will never go into the waffles where you make the microchips. And to me, a laboratory had to do work with coffee and coffee being spoiled on the computer and people soldering and, This is our first laboratory at K3, which is in the cafeteria, because at the School of Arts, we had no laboratory, So I jumped from the white pajamas in just 3 years this direction. And you might think it's downgrading, but it's the other way. It's super upgrading. It's like you feel like technology has made it this far. You can use it anywhere, and you can create it anywhere, almost anywhere. You, of course, don't make the chips at the cafeteria of the university, but... And it also changed, we also changed the way people communicate. So I like to put this example at all times. It's like my students were building this device, and they needed to ask a question, and they didn't really know much about schematics, because after 5 weeks, you cannot really teach people about schematics. It's not that easy. Schematics is a very complicated engineering language to express circuit boards. But you cannot really see it in this picture because it's really bright, but maybe you can see here there's a small scissor. Can you see the small scissor on this side? Well, this means that you can cut this thing here and on this other side, and you can apply power, and these LEDs will shine beautifully. And this comes in a 50 meters long stripe of LEDs, and you can cut them at different places. As a matter of fact, you can cut this thing anywhere in between the LEDs. But my students didn't know, so they were asking me, can we cut it on this side or on this side of the component? It didn't matter, but I didn't expect them to know the answer either. So they sent me this email to ask, please forget about the F word. And this is what they did. This is what they did. And it's an interactive rocking chair. And as you rock the chair, the light simulates water, and it goes back and forth. This was exhibited at Ars Electronica 2006, in September that year. There are some new paradigms that we are working with. Okay, visual programming is not such a new paradigm, but and physical computing, as explained earlier, is not such a new paradigm. It's already almost 10 years old. But we're starting to talk about interlace programming, which means what happens when when you build electronics, the first thing you do most of the times is that you build the hardware, or you make a humongous analysis of what do I need. I want to make all this computing power because I'm going to make encryption low level and so on and so forth. And then, so you build this platform, and then you start putting software in it. And then you realize, okay, we made this mistake, and you make a second iteration of the platform and make software. But, you know, it would be so much better if you could just like, you apply a bit of hardware, you try it out, and you do some software, and then you check the documentation and so on. A more interlaced process for learning. So that's what we're working with, so that you are not anymore, you know, having to go through this, okay, I make the hardware, have to abstract and believe in a lot of stuff, and then I can write the code. The ones of you that attended the course that we did now, that was a bit of an experience of interlaced learning. You know, you put something, and then you write something for that one specific light. You see that it works, and then you add a push button, and then you write something for the push button, and then you grow, and you spin the thing, and it gets that this big. And after 2 hours, you look back, and you realize, I climbed up this mountain, right? And you don't even know how you made it that far. That's part of the experience. And I will not talk about tangible coding, because that's my secret project that I carry with me. I'm sorry. So I think we've changed the idea of prototyping a little bit, because we brought prototyping from being something that you do in the industry to be something that you do in the classroom, to let people build something that's like a one-run thing to measure the temperature or to measure acceleration and then use it, right? So to me, it's very important. To me, prototyping is getting to express concepts by compromising some of the functionality, but keeping the status of interaction intact. So you have this mock carton, and the user will come in here and believe it's the real thing, you know? And you have to like smash his face, like, no, come on, it's not real. It's just a toy. You cannot buy this thing. Well, you can also fool people and let them buy it and then run away. But it's about building it quick, letting people experience it, see how it feels, and going back to the drawing board and do it again. This is an example of an egg timer. As a basic experiment, I asked people to make me a soft-boiled egg. And I asked, like after 2 days working in class, I tell them, okay, make me a soft-boiled egg timer. And Bjorn, who besides being pretty quick, he invented something, a building system made in cardboard that he called 9 centimeters is enough. And I know that sounds really bad, but it's because there is 9 centimeters between these two pieces of cardboard here. And inside this board, inside this box, he will put the Arduino board and a battery, and then he will build everything on top of it. And it was his modular cardboard system. And by the time he did this, we had no laser cutters. He was cutting everything by hand. So with his modular system applied to laser cutters right now, he could build things in cardboard in no time. So his egg timer is one of the best ones I've ever seen, made in 2006. When we put it down, the LEDs, the first LED that is lit goes off and goes in here and so on. So it's like a, you know, like a hourglass, but made of LEDs. And by the end of the thing, it beeps. And it remains there because it made it to the end. If you want another boiled egg, you turn it back again, and so on. Very simple interaction, conveys the meaning, and it totally shows that you can boil a soft-boiled egg in cardboard. Another thing that happened with Arduino is that we came to realize we were the first successful open source hardware business. We never intended to be a business, okay? I want to make this very clear. We wanted to be a foundation, but we realized that being a 5-people operation, it was really hard to be a foundation. We would spend the little money we were making into paying a secretary and a president instead of, you know, trying to pay our flying tickets to meet up and build more things. So at some point, people started to ask, okay, how would it be to make this idea of like giving away this design of the hardware available for everybody else? So a bunch of people got together and created the open source hardware definition. And a bit later on, the CERN Institute in Switzerland helped creating the open source hardware license that is available now. So if you want to make anything hardware, you can make it as free as you can make software. Okay, just keep it in mind. So I have a lot of other things, but I want to open the floor for questions.
And actually, David, I think that we're going to take the questions over